Let us solve another question. The cost function in rupees per hour for 3 units in a thermal plant are C1 is equal to 350 plus 7.2 P1 plus 0.004 P1 square rupees per hour. C2 is equal to 500 plus 7.3 P2 plus 0.0025 P2 square rupees per hour, and C3 is equal to 600 plus 6.74 P3 plus 0.003 P3 square rupees per hour. So we already know the general format of cost function. So we have drawn the cost chiara, the input output chiara. It was parabolic, and we got the equation for fuel cost as alpha P1 square plus beta P1 plus gamma. So that's why this equation becomes like this. The curve is a parabolic curve, so we can represent it using a quadratic equation. So there are 3 generators in a thermal power plant, and the fuel cost of all the 3 units are given. P1, P2 and P3 are in megawatt. Find the optimum schedule for a demand of 600 megawatt. That is, if a total load demand of 600 megawatt is there in the power plant, find out the generation of each unit 1, 2 and 3. That is, the plant has to supply a power of 600 megawatt. അങ്ങനെയാണെങ്കിൽ ഓരോ ജനറേറ്ററും എത്ര പവർ തരണം, അതാണ് P1, P2 and P3. So we have to calculate the value of P1, P2 and P3. So now let us solve this problem. So economic load dispatch ന്റെ പ്രോബ്ലം ചെയ്യാൻ രണ്ട് കാര്യങ്ങൾ നമ്മൾ ശ്രദ്ധിച്ചാൽ മതി. First one, equal incremental cost, that is DCI divided by DPI is equal to lambda for all the units 1, 2, 3 etc. n. So here we have 3 units, and incremental cost of all the units should be equated to lambda. And second one is the power balance equation, that is total demand is equal to total generation. So we have 3 units, so total demand is equal to P1 plus P2 plus P3. So now write the incremental cost of each units. So for the first unit, DC1 divided by DP1. So C1 is this. So 350 is a constant, so derivative is 0. Derivative of 7.2 P1 with respect to P1 becomes 7.2 plus 0.004 P1 square. Derivative becomes 2 into 0.004 P1, that is 0.008 P1. This should be equated to lambda. Similarly, DC2 divided by dP2, which is equal to 500 is constant, so derivative is 0. Derivative of 7.3 P2 becomes 7.3 plus 2 into 0.0025 into P2, that is 0.005 P2, which is also equal to lambda. DC3 by dP3 can be written as 6.74 plus 0.006 P3. So this is also equal to lambda. Now from all these 3 equations, write down the equation for power generations. That is, from here write the equation for P1, which is equal to lambda minus 7.2 divided by 0.008. Lambda minus 7.2 divided by 0.008. Similarly, from here P2 will be equal to lambda minus 7.3 divided by 0.005, and from here P3 will be equal to lambda minus 6.74 divided by 0.006. So now we have the equation for P1, P2 and P3 in terms of lambda. Now substitute the equations for P1, P2 and P3 in the power balance equation. So we have P1 plus P2 plus P3 is equal to PD. So P1 is lambda minus 7.2 divided by 0.008 plus lambda minus 7.3 divided by 0.005 plus lambda minus 6.74 divided by 0.006, which is equal to total load demand PD. So here total load demand is 600. So this is equal to 600. So now solve this equation and calculate the value of lambda. So same as in the previous question. So rearrange this equation. So lambda minus 7.2 divided by 0.008. This can be written as lambda divided by 0.008 minus 7.2 divided by 0.008. Lambda divided by 0.008 minus 7.2 divided by 0.008 plus lambda divided by 0.005 minus 7.3 divided by 0.005 plus lambda divided by 0.006 minus 6.74 divided by 0.006, which is equal to 600. Now take lambda as common. So lambda into 1 divided by 0.008 plus 1 divided by 0.005 plus 1 divided by 0.006, which is equal to 600 plus take all the constant terms towards the right hand side. So 600 plus 7.2 divided by 0.008 plus 7.3 divided by 0.005 plus 6.74 divided by 0.006. Now solve the left hand side as well as right hand side. So while adding these two terms, you will get lambda into 491.666 equal to, and right hand side becomes 4083.33. So calculate the value of lambda. Lambda is equal to 4083.33 divided by 491.666. So lambda becomes 8.3050 rupees per megawatt hour. So we got the value of lambda. Now calculate P1, P2 and P3 from the expression in terms of lambda. So we have P1 is equal to lambda minus 7.2 divided by 0.008. Lambda minus 7.2 divided by 0.008. So lambda is 8.3050 minus 7.2 divided by 0.008. So you will get the value of power generation of unit 1 as 138.125 megawatt. Similarly, P2 is lambda minus 7.3 divided by 0.005. So substituting the value of lambda, you will get the value of P2 as 201 megawatt. Similarly, P3 is lambda minus 6.74 divided by 0.006. On substituting the value of lambda, the value of P3 becomes 260.833 megawatt. So these will be the generations of units 1, 2 and 3 in order to supply a total load of 600 megawatt so that total fuel cost is minimum.